Let me just start with a couple of specific comments to level set the stage. And I will start talking about what's happening in the manufacturing industry at large. And let me start saying that for the first time in many decades, technology innovation has outpaced business process innovation. And if you take a time to think deeply about this, it will be clear to you that the digital transformation is not about software or technology. It is about innovating on business processes, but this time thinking freely without any technology constraint, as it has happened in many years so far. And this is important because we have observed that this brings greater pressure to manufacturers to transform their business fast or faster than ever before. So now here's an interesting point. I want to call your attention to the center of this slide. Two specific research findings are important, one from PwC and the other one from McKinsey. Both firms observed that it is possible to simultaneously achieve revenue growth and cost reduction in your business. But this is as long as two things take place. First, a well-thought digital strategy is formulated. And secondly, that the true transformation of the operating model is actually ongoing at the moment that you are using digital as well. And this goes hand in hand with the design principles of the fourth industrial revolution. And that is vertical integration, horizontal integration, and collaborative engineering all the way from a supplier to a manufacturer to the customers. So these principles call for achieving new levels of business value across the entire network. And in few words, that means that you're pursuing digital excellence for value co-creation in the entire value chain. So let's talk more about digital excellence and the need of a new class of digital twins. What industry leaders have experienced so far is that there are three key drivers to achieve digital excellence. And that's the ability to blend physically and, the physical and the virtual environments. That's number one. Number two is the ability to hold higher quality of interactions between humans and machines and enhance collaboration across the value chain. So in today's sessions, we will take a deep dive into these three drivers, because when you think about all these and you put them together, this is essentially what defines the new class of a digital twin. So for you to succeed, you need to start using the new digital twin, which must be intelligent, collaborative, interactive, immersive, and fully contextual. It needs to be a substantial replica of the physical network and not only the objects that we used to model before. Now, the other aspect that I want to emphasize today is the potential role that Microsoft can play for your business. See, we have vast experience on building and implementing innovative digital capabilities. On the other hand, you have experience at finding ways to achieve operational excellence and business excellence and manufacturing excellence. So just as you continually strategize to pursue this operational excellence, you will soon also need to focus on building strategies to achieve digital excellence. And that's the area where we want to partner with you, because we want to help you excel at doing digital. So we've been working with leading companies on industrial IoT strategies for the past 5, almost 6 years. And we have learned many lessons by heart. And at this point, I want to introduce you to this kind of mindset or this framework that we have developed that touches upon people, processes, and technology. At the core, this is what we call the 4 digital pillars of transformation. And when we work with you, we bring together the fundamentals, which are our industrial IoT partner ecosystem, which includes not only SI and ISV type of relationships, but also strategic relationships with PLC vendors, with network communication companies, with semiconductor industries, with the industry standard organizations, and with others that we will discuss in some other webcasts down the road. We build upon our secure and interoperable platforms, and we guide all these efforts for you to achieve business and process transformation. That's how we apply our digital knowledge, and that's how we can help in transforming your business. Now, for today's purposes, the most important component of this framework is what you read at the bottom of this figure. I mentioned a few minutes ago that there are key technology enablers to achieve digital excellence. The ability to blend physical and virtual environments, and that's what we mean with the mixed reality environment. Second, the ability to hold higher quality of interactions between humans and machines, and that's creating cognitive and intelligent equipment. So arming your equipment to think naturally, almost like human. And then last, the enhanced collaboration that can go across the entire value chain. Now, I also said earlier that these three define the characteristics of the new class of the digital twin. So let me explain what this means in specific detail by describing the evolution of what we have seen in digital twin and how this is different in today's world. The digital twins have evolved rapidly, pretty much over the last 2 decades. And although the NASA was probably the first one to experiment with things or predecessors of what we know today as digital twin, it was not until 2002 that the concept of a digital twin was first introduced. This was in the University of Michigan by Dr. Michael Greaves and John Vickers. At that moment, these served only as for modeling and analysis purposes of the physical elements. And then between 2003 and 2014, the digital twins were used for things like product design and simulation by creating 3D models as digital companions. Again, mostly used in the product development practices and engineering as well. Now, in the latest years, up to, I guess, I want to say about 6 months ago, the digital twin has started to incorporate advanced analytics, and it has also added key processes that conform what is called now the digital thread. And it is probably used now into various operations in the entire value chain, not anymore only on the design or the product engineering side of the house. So now you find a lot of these digital twins mostly to provide better services and to increase the customer satisfaction level with these new services that it provides. But it still fits only collaboration via visualization. And it replicates comprehensive environments, but still very specific to some specific objects. Now, these 2 last columns, or the center columns that you see on the screen, is where most everybody gravitates today when they talk about how digital twins come and the value that they deliver. A new class of the digital twin is represented here in the far right on the slide. And it differs from its predecessors in that with today's technologies, you can replicate the things, but you can replicate those along with its cognitive capabilities, as well as the contextual information that lives with it. And it reaches a point in which, in a mixed reality environment, the equipment starts behaving like a human. And because of this, the equipment is capable now to interact with humans without any geographical, time, or business boundaries. So if you think about it, this is the true integration. This is the integration vertically, horizontally, and the integration with the customers. And all this is happening inside an immersive mixed reality environment. So At the end of the day, if you think again about these new capabilities and this new class of digital twin, this is the one that fits the design principles of Industry 4.0. So if you are morphing your business to achieve greater levels of value based on the fourth industrial revolution, you must also use tools and technology that fits that need. One of the best examples I have seen so far that is available today is what we're doing what Schneider Electric end up working as a prototype for internal operations improvement. And now it's available also in the marketplace. And what you see on the picture on the far right is the ability of an intelligent equipment calling for help to the maintenance personnel only when we need or when the machine needs that help. And this is after self-tuning because it's a very intelligent piece of equipment. So think about condition-based maintenance by a human almost, or an equipment that behaves like human, calling for assistance for a peer, which in this case happens to be the maintenance person. Now, the first individual is guided by the intelligent equipment on actions that need to be taken inside the mixed reality environment. And later on, an engineer who can be co-located with the operator or the maintenance personnel, or also in a remote location, helps both the maintenance personnel and the equipment be a mixed reality as well. So this is a great showcase of collaboration across organizations inside this cognitive mixed reality environment, and Seamless reflects all these actions into the physical object that lives in the plant floor. So the result is that they are achieving higher level of productivity for people, have a higher level of utilization time of the equipment and uptime of production, and is raising the bar for exceptional customer service. That's a new class of digital twin, delivering tangible business value today. So now let me pass the mic to Simon so he explains the architecture behind the scenes and how you can leverage all this technology today. Simon, the floor is yours.
Great, thank you, Enrique. Over the next 20 minutes or so, I'll dive a little deeper into what defines and constitutes a digital twin, then cover the technologies and architecture, and then I'll wrap up by looking at a few of our customers and where they are on their journey towards a digital twin. Okay, let's dive in. The easiest and simple way to define a digital twin is a virtual instance of a customer's smart connected physical product, which has three major constituents that you can see up on screen. In my example, the first is illustrating a market view of multiple models of a product, and what you're looking at is actually just industrial products. This is a dozer. And they exist in different locations for different customers. So we have a very full and complete view of all of our products that are in market, broken down by customer and by geography. The second is the digital twin itself in the middle that represents the physical and digital components of the product itself, so that we have a really good view into all of the mechanical and electrical and digital components of the product. The third is the enterprise, and it's all the expected insights, the beneficiaries, and the product lifecycle states that we would expect to see about this particular product from the customer. And this is what makes digital twin really different, is that it's unique to the customer, but it can intelligently include a global fleet view and insights, as well as your internal processes. So there's really no better way, in my opinion, to get a full and complete view of what's occurring for the customer as they operate the equipment. Okay, so next, I just want to talk a little bit more about the actual architecture of a digital twin solution, and I'm going to break this down in levels. So just to begin here at just a high level, there are really a huge amount of smart connected products that are just going into the market everywhere at the moment. I think everybody would understand this. So it's a situation where we have a lot of products that can communicate. And this is really critical because without this, we don't have a digital twin strategy. So we have to have smart connected products, or we have to have a method to make them at least connected, if not smart. So what I'm really representing here is, again, another sort of three-part view of the sort of highest level of architecture. The first is the product itself, and as I mentioned, it has to be capable of collecting information through sensors, or it perhaps has an embedded computing system, and allow access to all the device parameters and telemetry. This is the notion of a smart connected product. And of course, this is very unique to the customer, but it's fleet aware. And I like to kind of reinforce this as much as I can, because this does make digital twin quite unique in many ways. The second is the platform to facilitate the digital twin itself, to form the actual virtual representation of the physical product, of course. And you need to have a visualization method for the data or the information. And I mean, this can include, really three major things, which is either mechanical, electrical, or digital. And so being able to visualize these data streams is really critical. Furthermore, it can consider enterprise systems to form a complete picture of, its genealogy in effect. So you can actually see not just the physical notion of the product as it's operating, but also you can see things such as how it was designed or how it was manufactured, as well as how it's actually being maintained. And all of those may differ very slightly, as you may know. Now, what's kind of critical is that, as Enrique was saying before, that the digital twin can also have a notion of artificial intelligence behind it, which allows a natural human interaction, which can be done through voice or vision. And this allows for the twin to autonomously generate insights or even recommended actions. So while digital twin can be very high touch, and we can see into what's happening with the customer, and we can also have the intelligence in the background that certain actions can be done actually on their own by the system. And then to kind of wrap out this overall picture, high-level architecture, the third part, of course, is the services that can accompany the digital twin to add value to the customer and to the enterprise. It's really twofold. In particular, I'd say there is an ability to learn from the way a product is used to accelerate innovation. And it's an incredible insight when you can really look at a product and say, well, it's being used in this manner. Number of functions are being used or not in this sequence and in this priority. It can provide a completely new level of insight into a product. And it takes away a little bit of the human emotional response. So if you were to ask, how are things going with this equipment or with the product, you may get something very different from seeing the way that it's actually used by just looking at the data. So to kind of summarize this, I would say that, importantly, there is a really high, customer support angle to this as well, because the services that you can provide back to the customer increases the overall value of the product. So while we may be able to learn from it to be sort of more innovative and to plan a next product generation, something I'd say that is more kind of prescient here is that we can start to improve the operation of the product as it's used, which of course increases its value for the customer. Okay, so you might be wondering, what does Microsoft really bring to the table for your digital twin strategy? Quite simply, we have the technologies that work together seamlessly to deliver a comprehensive and connected platform that comprises the physical product all the way through to the enterprise. And what this really means is that we have the right type of devices that can accelerate 3D on screen or in a virtual world or with mixed reality, so that we have the physical embodiment that can be visualized of the digital twin through a number of different mediums. We have the cloud services to simulate design choices as well as parameter-driven real-world conditions, and a built-in method to 3D print from virtually any application. So what this really means is that while you could have visualization that may occur in any sort of 3D application, we have a method to take the 3D information itself and also go to print. And this can be extremely helpful for prototyping purposes, for temporary part replacement, for additional learning and innovation purposes. And that's a very seamless process throughout our platform. Then, of course, to sort of wrap things out in the overall sort of technology portfolio, we also have the kind of the brains behind the scenes, what I would call it, which is all the cloud-based services that are required to connect devices, to create the analytics, perform machine learning, and as we were talking before, the cognitive services such as bots and language and imaging process as well. So we take the notion of a smart connected product and now make it artificially intelligent so that it can perform certain functions on itself based on a learning system. So it's, if you like, it's a product that can progressively learn from its own use and report that back, of course, and then we can take actions for design or for customer services purposes, and even learn if there are things that are occurring along the way, such as quality issues or procedural problems in the way that the product is actually manufactured. Now let's just have a look one level deeper. So let's go into the system architecture for a moment and have a look at how it would actually orchestrate within your organization. Okay, as I mentioned before, in kind of my high-level overview of digital twin, you must have connected products, whether they contain an IoT client, commonly seen in consumer, automotive, and aerospace applications, or require a field gateway, often required for, say, production machinery and some legacy industrial equipment. This provides a connectivity with the cloud, its services, of course, the overall solution experience, and integration to build out the digital twin solution overall. However, we know there's much more that's required, such as integration with line of business systems for customer service and field service, as an example. This is actually where our cloud, Microsoft's cloud, provides a comprehensive set of capabilities, because we can go from device through to service and then out to application and create a very unique bond and a digital thread between the customer and the enterprise. It provides a method to create and deliver the new services that are driven by the connected device data itself, making it uniquely valuable for the product and the operator. And that kind of seamless nature of all the systems being combined together is what we believe to provide an advantage in creating a digital twin strategy. Further, it's it's critical that you have integration with some of the primary authoring systems, such as computer-aided design or CAD, computer-aided engineering, and any of the associated data management systems that run with them. And this is to ensure that designers and engineers can simulate outcomes with real-world parameters, but also design for situational performance and reliability versus just specification conformance. And in my mind, I think this is kind of nirvana, when the products can actually be reporting back to the design and engineering teams, and they can use this information to simulate a new outcome, which of course can really influence the way that they take a design decision or an engineering choice. In a similar fashion, this is actually true for things like supply chain systems that can benefit from having actual performance against components, And this is a new method rather than just considering sort of cost, volume, lead time as you would. It can now look at actual field performance and can do so in virtually real time, which is quite a step forward. It's also true for manufacturing execution systems as well, because they hold a critical record pertaining to the DNA of the digital twin, or at least the DNA of the real product, and that includes the practices and processes that were employed to build the physical product in the first place. So when you think about it, we're now getting enough information back that we can also refine something such as assembly process, or we can look for any faults that may be occurring in procedures causing a quality issue, or trace it back to the supply chain even. Now, underlying this architecture, there's two data models that I want to talk about that bind all the information. One is offered through our cloud. This is part of Microsoft Azure. This is the Common Data Model services. And there's also the Common Data Model offered through Dynamics 365. Now, the reason why we would want to have this is that it does allow for a very resilient application to be built, so that as things change over time, the application is not going to break per se. It can still live on and grow as the information changes and as new services come online. And this is really important for agility. But there's something else that I feel we really need to make it truly resilient, which is a standard method of looking at the three different states of a product through its own life cycle, such as designed, as built, and as maintained. And in this particular case, I'm very interested in PLCS, which is Product Lifecycle Support. I think is a really good standard that covers all of these bases, and one that, in fact, I would suggest is worthy of looking at in this type of instance, and certainly a great candidate for unifying the way that information is presented back to the engineering team and then throughout the product lifecycle itself. Okay, so now I'm just going to quickly wrap up for you. And just one more visual for you, which is just to talk about the experiences that we've had today with many great companies around the world. As you can see, some of those represented on this chart. And what you'll notice is that getting to digital twin is a journey. And for us, we really believe that it kind of starts with the basics, which is remote monitoring. So at this very base level, you already have a digital twin. You may not have all of the different assets to get to visual representations and simulation and so forth, but you do have direct insights into the customer and into the operation of very specific equipment, so it definitely qualifies. Now, having the information itself does provide a ton of value, but I think it's kind of interesting in a way what you can do with the information once reported, and so we have an application for that called Power BI. And having the sort of business intelligence tools behind the raw information coming in from the product does provide a lot of analytic capabilities and does provide the additional insights. Once you are there, there's quite a lot that can be done to kind of move upstream. So the next level, of course, would be predictive maintenance. And this is where we can start to apply the historical information to come forward with a prediction about performance or reliability or some other factor that may affect overall operation, or in some cases it may provide us insights to get the right type of optimization that we need. Now, finally, we would say that once you have these steps underway, then of course the next part of the journey would be to go to connected field service, because now you have the ultimate insight into the customer. But we need to sometimes look a little higher again and start to get to the representation beyond just the data itself. And that's where having a 3D or a 2D visualization and the right type of interaction with that information is really critical. And so we do see that as being really high value, especially in a field service context. And going back to some of the things that Enrique was mentioning earlier, this can provide a really great interface into the intelligence of the product itself. So being able to speak to a product, being able to push visuals to a product and have an interaction with it as if it were actually another person to a certain degree, is a really quite impressive feature, but also highly productive for field service personnel. And then finally, I would say kind of the nirvana situation is where we can really get to a fully integrated system that can simulate outcomes, that does have a high degree of human interaction to it, and is connected back through engineering. So while we definitely know that in the early days when this was defined by NASA, they were really beginning with more in their engineering system, and we're looking at sort of 3D representation with perhaps playback information or even live streaming. We're seeing this as being perhaps a slightly different journey, which is begin with the remote monitoring and then step your way through a value chain, eventually coming back to integration with the engineering system. Once there, it now has an incredible amount of value beyond just being able to stream telemetry from a product. Okay, so I'll just wrap this out, and I just wanted to make one kind of final point here, which is the most valuable part of a digital twin strategy in my mind is really the ability to create new customer value through a very personalized service and experience for the customer. And then, it's twofold, because there is also this aspect to it which allows the enterprise to really learn from how the product is operating, not just individually for a customer, but at a fleet level for the customer, and then beyond that, out into the entire market. So in that regard, it really is the ultimate intelligence system. Okay, so I just one more quick slide here to wrap things out, and then we'll move over into Q&A. So if you would like to learn a little bit more, or if you would like to partner with us on your digital twin strategy, then we have a number of different ways that you can engage. We can start very simply with a solution strategy workshop. We can help you with an overall solution design session, and even go to executing a proof of concept, which might begin just with remote monitoring as an example, so that we can help sort of build that architecture and vision to go forward so that it's sustainable as you go on your journey. And of course, there's always more information that can be found just through our website, including many great customer case studies that go into more depth than we have time to do today. I know that we have a few questions that are coming through, and now I'm going to ask Enrique to help me out so that we can answer a couple of questions for you.
Yeah, excellent, Simon. One of the first questions that we have is, what is the difference, like basically the contracts between what Microsoft offers as digital twin, since GE has been doing this for many years, a couple of years is the question saying, what is the difference between Microsoft approach to the digital twin and GE's digital twin, as an example, if you can contrast that. That's the first question we have here.
Yeah, I think that's a good question. I think that what GE has put forward is part of the overall picture and vision. I think they've concentrate, or they do concentrate on predictive maintenance and understanding the parameters of the actual product itself, and perhaps what makes this overall picture a little bit different, and indeed this is one that GE can be part of, by the way. It's definitely not exclusive. We have an inclusive architecture in this regard. I think what, sort of where we differentiate and where we go a little bit further is we do have the integration through to things like, customer service systems, through to field service. We have the relationships with, many of the computer-aided design solution providers as well, so that we do have a good understanding of how our product lifecycle management works. We do have a good view into things like manufacturing execution. So I would say the big difference here is one of just breadth of the portfolio. And as I mentioned before, you could have a solution from GE that actually runs within this architecture. So in some regards, I would say, there's not a great deal of difference, because when on one hand, digital twin is digital twin. So there is, in some ways, not a great deal of difference. And in others, I would say that we do have a very comprehensive view of digital twin that can grow over time. So I would answer it that way.
Yeah, excellent. The second question we have here is also in your field, Simon, so maybe you can answer. It says, how do we unlock the value of digital twin when PLM vendors hold those in ransom on accessing their 3D models? So it's more on the side of the PLM vendors dominating the space, I guess. So.
Yeah, thanks, Enrique. That's a good question too, and I hear this one a lot, that the PLM vendors or the CAD vendors hold the data to ransom. It's a sad indictment that people think that, but of course, all the vendors support open visualization formats. And for example, Microsoft is a JT Open partner. We're very familiar with the STEP AP protocols and so forth. And I think there is an opportunity to create the sort of the traditional downstream lightweight 3D versions of the CAD geometry that can be used for the visualization component of digital twin. And in my mind, I actually think this is quite a smart move, because you really would not want to have live streaming data going into a CAD system. I think that could really disturb the way you're thinking about doing design. I think you would more want to have a state where the product is at release, and so you have that release version of the way it was actually designed. You have the lightweight representation of it, and then you can use that for visualization performance or for visualization purposes, to see how the actual mechanical structure itself does actually perform, or indeed something like electrical schematic, or even just system diagram and so forth. So not just limited to 3D geometry here, but any sort of visual representation of the design could be pushed into a downstream format, and then that becomes the visual face of the digital twin. And in fact, that's a little bit like what we do with HoloLens. So with our mixed reality device, we have a downstream format rather than just having CAD native. Actually, for that purpose, there's a little bit of separation there. Does provide some advantages, in my opinion, and does allow us to then access a number of different devices and platforms without having any sort of reliance on the engineering system necessarily being active or having to be in every location.
Yeah. Excellent. So there's another question which is a little bit of similar to the first one, but it's asking, can you elaborate about how the new class of a digital twin differs from others? So let me answer that on the practical side or the business value that people are experimenting today. When you think about the digital twin that exists in a mixed reality environment, the fact that it's mixed reality, it's already a different way of interacting with things. And then the differentiation starts to come more strongly when you think about the level of intelligence that parts have in the physical world and how this is replicated also in the mixed reality environment. Because at the end, with that level of intelligence and the level of collaboration that you can achieve inside the mixed reality environment, that is something that is becoming unprecedented, and that's part of the transformative aspect here. Because then we start seeing business value delivery in terms of not having to wait to understand the larger volume or variety or velocity of data that needs to be collected and then sent elsewhere for analysis and then come back with a decision, right? In this interaction, think about technologies like HoloLens being a self-contained computer that actually gives you that ability to interact in real time with in-process or in machine that is in operation, to start analyzing and getting the feedback loop into that. So when it comes to the level of intelligence of the equipment for self-healing, and then an engineer capable to interact with that self-healing process, that's what makes it completely different. That's where we're calling it a completely new class. Now, the other element that I want to emphasize here is that only because it's a new class, it doesn't mean that that is the digital twin that you need to use for every kind of flavor or any kind of problem that surfaces anywhere in the entire value chain, right? The ability that now you can play with this technology from one extreme to the other one is what gives you the ability to apply the level of technology required for the problem that you can resolve at the time. So the problem at hand. So depending on where you are on the value chain, you will want to have a very robust kind of digital twin or a simpler one. But the key point here is that most of the ability that you have today is something that you didn't have before in that proximity. So hope that answers that question on that angle. So let me jump into.
Enrique, if you don't mind, I'll just quickly add in a couple of quick comments here. So I, I would summarize this and say there's really two things that make this kind of a new class. One is we do have the sort of enterprise intelligence, let me call it that, so that we can look into the way that a product was manufactured. We do have the notion of genealogy. We do have a customer service view. We can look at things like support incidents and so forth, and a full record of customer interaction that may not necessarily have come from the machine. So this is just human interaction that can also be part of the overall digital record for the twin. And then finally, really where we're heading with it is to make it artificially intelligent, for want of a better word, so that there are the cognitive services behind the twin that allow it, as you were just saying there, Enrique, I thought was really good, that it can create some of its own outcomes. And I think that overall really means that we have something that is very intelligent and very aware, from it almost the moment of its conception all the way through to its operation and use.
Yep, excellent. Thanks for that, Simon. Questions keep coming. I want to pick on this one. What is a realistic time frame for the digital journey from remote monitoring to connected engineering? And it evolves into also any disruptive technologies that might help accelerate this. So let me take the quick answer, and then I'll pass the mic also to Simon on this one. Most of the scenarios that we have discussed in terms of the logos that you saw on the slides and the things that we actually demonstrated a couple of weeks back in Hannover Messe are real life examples of people having in production or near production kind of environment today with this kind of connectivity from remote monitoring all the way to engineering. In terms of timing, basically my answer to that is it's happening today. It's not something that is going to happen in the future. It's a deal of how fast can you implement. So on the angle of creating a remote monitoring capability and then connect engineering to that, we're seeing that these projects are measured these days in a matter of weeks. I want to say that the fastest that I have seen so far that go from pilots to POCs to pilots and then ready for production grade are anywhere in the boundaries of 8 weeks to 10 weeks. When the scope is well defined and when the precise elements of the business transformation is also defined. So don't forget the fact that this needs to come together, right? The digital enablers, in addition to the clear understanding of how the operating model or the business process need to change. So it's happening faster than ever before, and it's realistic based on the experience that we have seen. Simon, you want to add to that?
Yeah, thanks, Enrique. I will add just a couple of quick comments. I would say, the journey is much more than just the technology, actually, because I've worked on programs where we've been able to successfully stand up a proof of concept for something like predictive maintenance or for remote monitoring in just 30 days. Now, it was a lot of work to do that, of course, in 30 days, as you can well imagine, but we're able to do it successfully in that time frame. However, what took much longer, maybe spinning out to 3-4 months, maybe even longer than that, is really the people, practice, and process angle behind this. So while we might be able to do the technology demonstrator, there is the sort of operational part of this as well. So if we have to think about it as maybe change management, that's a good way to go, because having this type of intelligence being reported back, it does require a change in the way that people think about their work. So if this is for customer service and before they were troubleshooting with a customer over the phone without any type of visual or intelligence, now they may have an interactive 3D model, they may have a dashboard that's providing them with indicators. There is a lot more information at hand that they now need to learn how to use and how to action. So to take something from just a technology proof of concept all the way through to something that's production live can really depend to a certain degree on its scale as to how big that program would be. But in sort of round terms, I would say a very quick program to launch something might be 3 months, all hands on deck, probably 6 months to get fully into the enterprise and out and deployed. And then at the 12-month mark, what we generally see is people are beginning to expand the overall scope and beginning to scale out and grow the program. So for many of the customers that you've seen on the slide that I represented through the journey, that's been very typical for them. So a very, very good quick start, work through their people, process, and practice, as I say, through to sort of field deployment and so forth. They can be on that journey from anywhere from sort of 3, 6 to 12 months. Getting to engineering, and there is a little bit of a secret formula, I think, here. We're talking about just the disruptive technologies. I don't know if you would necessarily call a data standard disruptive, but if it's not being employed in any fashion, then it might be disruptive. But it's another reason why I'm just a really big fan of PLCS. I just think that it provides the unification and some ubiquity that you can transport the information around, which gives you a lot of flexibility, in my opinion. And I think that the more we move to these type of standard methods of documenting product record and so forth, the shorter these programs will be and the easier these programs will be, because many environments are not heterogeneous for people. They have 2, 3, 4 different CAD systems, maybe one PDM system, a data management system, maybe, or perhaps even 2. And that can be a bit of a blocker for people that want to go to digital twin for an engineering system unless they're planning to make it monolithic. And I think for most companies, they are looking for something that's going to be more broadly applicable across the organization. They don't want to be held to ransom by the tool, is something that we talked about earlier. They want to have that flexibility. So I would say that journey could also be within that 6 to 12 month journey, of course, but the devil is in the details. It's about defining what the information will do for what purpose and what the desired outcomes will be. And then, of course, the change management aspect of this, which is teaching engineers and designers how to use the information in a way that's not going to disturb the process that they currently have, but hopefully shorten their cycles and provide them the additional insights that they need.
Excellent. Thanks, Simon. Hey, we're coming to the end of the webinar. There are still more questions. I want to answer one last one that it's a summary of 3 questions that are right now in the file. And this is related to when is this going to become mainstream and apply to the masses? Let me answer that one quickly, and then I'll pass the mic again to Simon. And then for further questions, we're going to try to respond via email, the questions that we have here for the persons that are asking. But also feel free to connect with us moving forward via our contacts, via email, Twitter, or LinkedIn as well. So to answer the question about when is this becoming mainstream, in terms of the technology capabilities, it is, when I started the conversation, I was saying that technology has advanced a lot faster than the business process innovation. And I think this is one of the examples of that. Technology-wise, we have several different tools and capabilities, and we have built solutions and put them in the market together. So from the technology perspective, I think it's ready to start being adopted as mainstream. I think that as companies and as people get creative and innovate and start innovating into what is the new operation model and how we see that the organization structure is going to change, I think that's where people are going to realize how fast and easy and inexpensive it is to do these kind of projects, right? Before there were the days in which people will spend about half a year getting approvals and finding the perfect storm and the perfect use case to do this, and then getting the approval of the budgets and all these kind of things. And nowadays, quite frankly, it's a lot faster to get a quick mini POC in a matter of days to prove the immediate concepts that are out there. And so I believe it's more like people getting familiar with the technology and being able to actually seize the value that we have here. And I would close on my answer with the fact of what I also started at the beginning. When you do the entire digital transformation and you really focus on the three elements of integration, vertical, horizontally, and keeping the connection with the customer and the needs of the customer, that's when you see 10 times the value into what you are doing with technology. As opposed to people that just do flares of digital tests, they see a tenth of that value. They see 3% of revenue increase and 3 or 4% of cost reduction, right? Versus people that do everything comprehensive and quickly, they see 30% of both revenue increase and cost reduction. So I will encourage you to think holistically, because it's really quickly to actually take action and think and test and fail fast in order to move the practices forward. So Simon, you want to elaborate on that too and close the webinar?
Yeah, thanks, Enrique. I just would add a couple of just quick points here, is that for many people, there is some history with digital twins. So I think that for many, they really are looking for a method to get the machine data, the telemetry back into the engineering system. And that's really where it began. And it's certainly very understandable, because there is a lot that can be gained from that. But if we broaden the definition of digital twin and just think about the replication of the information coming from the customer and coming specifically from a product that they're using, then actually quite a few companies have been on this journey for quite some time. And that's what I've learned along the way, is that perhaps in the past, without having something like the cloud, they did not have the ease of access, or they did not have the sort of real-time performance. Definitely did not have sort of bi-directional connection with the products, but nonetheless they were looking at information that was very specific to a product with the customer, and looking to get the sort of insights and actions around that particular product. So for many companies, actually been there and kind of like staying there. But the intriguing thing to me, of course, is what happens when you can go beyond just the pure insights itself, but get into things like machine learning, so that you can understand what is likely to occur going forward, to get the additional intelligence and so forth. And that can be a very short journey, actually, to get to value. And then thinking about it overall, then I would most definitely say that, as Enrique was saying, this new class of digital twin is something that's very achievable by anyone that's already begun their journey, or anyone that wants to start their journey. So with that, I believe I have the honor of closing out our webcast for today. And so I'd like to thank my colleague Enrique for joining me this morning, and like to thank everybody who was able to join this webcast, and certainly for anyone that is watching it on a replay in the future. We would certainly appreciate any additional questions or any sort of feedback or interaction. In that regard, both Enrique and I are available through Twitter if you wish, and a couple of links you can see up on screen if you would like to get any additional information. So thanks again. On behalf of all of us at Microsoft, we wish you all the best on your digital twin journey and certainly hope that we can help you along the way. And with that, I bid thee farewell and happy digital twinning.
Thanks, everybody. Bye-bye.